In this short demo video, we will show you how to set up your SPAD512² single-photon camera system and demonstrate the use of our software. All information and more details can be found in the online documentation on piimaging.com/docs. Together with the camera, you will also have received a 5-volt power supply. Never use a power supply with a voltage other than 5 volt. There are also 2 USB 3 cables included. Furthermore, you will need your own C or CS mount lens or a C mount compatible microscope. To prepare the camera for its first use, we will first remove the end cap. Leave the CS to C mount adapter in place, like we do here if installing a C mount objective. It is very important to never expose the camera to light without an objective. Overexposure causes risk of breaking the sensor. For now, leave the lens cap on the objective. The camera uses 2 readout chains. We will refer to them as master and slave. The camera is normally employed with both halves, but the master part can also be used just by itself. The next step is to attach the 2 USB cables to both the master and slave readout. Also, plug both USB cables into your PC, preferably to separate USB host controllers to get the best performance. The final step to get the camera ready is plugging the 5-volt adapter both in the camera and a wall outlet. Always use only one of the 2 5-volt inputs on the camera. Once the power is connected, the fans in the camera should start spinning. On your PC, download the software from our website. Everything required is bundled in the zip file. Extract the zip in your preferred directory. On Windows, install the USB driver and the Visual C++ redistributable. On Linux, run the shell script to set the rules to access the USB drivers. Now you can change to the software's standalone directory and launch the software's executable. You should be greeted by the SPAD512² splash screen. The software opens with the live view from the camera. Since the lens cap is still on the objective, you will see just the noise from the camera. To eliminate the hot pixels, we run the calibrate noise command from the menu. We also run the dead pixels calibration command to get rid of the pixels with very low sensitivity. Now, we can remove the lens cap, and we should see the live view image brighten up. At the moment, we have nothing in front of the lens, so this is a good occasion to set up a target. For this simple demo, we will put a fan in front of the camera. The live view will automatically adjust the exposure time, but it is also possible to change to manual exposure to have better control over the image brightness. The slider on the left can be set to a custom exposure time. In the options menu, you can toggle the color scale from the default red, yellow, white to grayscale and vice versa. Switching to the intensity imaging tab gives us all non-gated imaging possibilities. We can set an integration time per frame, the number of bits we require per image, and external triggering. Setting a lower number of bits enables shorter integration times, and it will result in a sharper image of the moving fan. The acquired sequence will be stored on disk and can be easily played back on the right part of the screen. The Settings tab shows the current operating conditions of the camera. We can adjust the camera's operating voltages. A higher excess bias voltage, VEX, increases the sensitivity of the sensor. We can also see the temperatures in various parts of the system. The camera is cooled with a Peltier to lower the dark noise and improve its performance. You will also find the frequency of the connected trigger signals. You can run a speed test to check the performance of the USB connection, and you can see if remote software is controlling the camera. We refer to the online documentation for more information and some examples on the remote operation.